of Economics from the University of Jordan. I spent the first few years after graduation working in sales of e-commerce platforms and HR solution tools. I also worked in an oil factory for a while. After that, I moved with my family to the US, where the change of atmosphere prompted the change of field. And I saw that as the perfect opportunity to join a program that focuses on business analytics, which was an MBA, HR solution tools. I also worked in an oil factory for a while. After that, yeah, I moved with my family to the US, where the change of atmosphere prompted the change of field. I'm sorry, I saw that as the perfect seems to be a program that focuses on business analytics. So there seems to be a I also worked in okay, sorry about that. There was a kind of echo, so I'm gonna be lowering the voice right now. Anyway, so we're going to be talking about the objectives of AI. Why did AI come to be? And this is very important that we understand what's the difference between AI and what's the difference between just good old programming. Then we're going to be explaining the process from zero until the product is deployed. After that, from that explanation, we're going to be concluding the non-technical areas of AI, which will help us dive deep into this. These are the areas that we can participate. Then we'll follow that by examples from the world of AI on jobs that actually exist. Full-time jobs dedicated to the AI process that do not involve any coding or statistics. After that, we are going to try and equip ourselves with some concepts that help us dive into that world and maybe test the waters and see if we are ready to go into that. So, how did AI come to be? Why do we need to embed AI in our development of applications today? The reason is that we have used the rule-based approach for a long time, and it served us in doing many things, developing many useful applications. But the rule-based approach is the logic of a rule-based approach is that if the case is X, then decide on Y. So this seems very simple and very straightforward, but in today's world, we do not need something as simple. I mean, we cannot use something as simple to decide what the weather is going to be today, because our users need specific numbers. They need specific price predictions in dollar amount. They need the weather predicted in Fahrenheit or Celsius. So this is where you cannot write hundreds of thousands of if statements and then have the computer go through all of these statements, which is inefficient in terms of performance. That is why we need to study the data. We need agents that study the data. And by agents, I mean computer software. So AI consumes data of all possible kinds. And this means that many people know, but it sometimes is not very common knowledge. But data is anything that can be recorded out of some task or process or event. Data can be speech, recorded speech. Data can be an image, a video, and as we already know, numbers and text as well. So some of AI's most common areas are natural language processing, or NLP. NLP is used to analyze the news and analyze comments, tweets, reviews of products, and sometimes it's analyzed for sentiment of the users. If you want to pick spam comments out of a post section, you can use natural language processing, and it can be as simple as picking a few words up until using statistical models to decide on one thing or the other. Also, we have data science and machine learning, and as many people know, these two are used interchangeably. Data science is mostly the process. It's a broader process from data collection, the design of experiments that we would collect the data from, up until exploratory data analysis, producing visualizations, creation of these statistical models. Machine learning is more focused in the statistical model section. It involves more mathematical work. We also have deep learning, which is a bit more advanced than, not just a bit, but it is more advanced than machine learning. It not only it involves the calculations and statistics and mathematics, but it also focuses on computer performance, because it usually takes up a lot of computing resources. We have other areas such as reinforcement learning, where people create bots to play games for them, and chatbots, which are actually come from several of the areas we just mentioned, NLP and data science, and we have other subspecialties. So now we understand why there is AI in the world, why we need AI in our applications. Let's take a look at the process of AI, from a general point of view. So here we have the green circle, starting with the business understanding. Business understanding is mainly the understanding of the problem statement. Why do we want to start this artificial intelligence project? Why do we need it? Usually business understanding comes from first somebody who is in a specific area is observing a problem that can be solved with data. When this problem statement is proposed and is generally understood by the business team, the artificial intelligence team, and it is clear, then we would understand that, yes, we have those requirements, we want to translate them into technical requirements. Usually, when we decide what the problem is, we also are able to decide how we measure our progress towards solving it. So, as an example, we may want to build an artificial intelligence let's say a model that predicts the weather. So our business understanding of it is that we need this model, and this entails knowing that we need to measure the speed of the wind, the current temperature, and let's say humidity. So this is data that we know we need, and therefore we can see the darker circle over here saying data acquisition and understanding. This is very critical because whatever we feed to the model that we're going to talk about, and I'll be talking about models here, So if we know what to feed our models, then we are good to give the modeling. Usually, this is where the modeling to the AI workers. Usually, this part is the most technical part, because here is where where the AI workers, meaning data scientists, machine learning engineers, or researchers, this is where they choose the models that they see are best to fit the problem at hand. And this is where they also keep researching, and they keep trying with the data that they have until they reach an acceptable threshold. So these things are modeled in this diagram as they happen in parallel. Sometimes they do, sometimes they don't. But they eventually, when we're all set and we have tested our models, we deploy it to production, where we have, of course, with customer acceptance, many companies use that, like half deployment. They deploy some products to only some of their audience. After customer acceptance, this is fully deployed, which is the end. Of course, I kept these on the side, just so you know, there are many other areas. Some of these areas, the non-technical person can also get involved in, but this is mostly on a personal level, but this is what we need to understand. So now moving to a more solid explanation of what we just saw in that diagram. So a business model, a business problem is needed for us to start working in the right direction. And as we said, data is anything that can be recorded and can be understood by our systems and studied and analyzed. After that, we need to either establish sources of data. This means that sometimes data scientists have to design experiments in order to collect new data, primary data. Sometimes we have to consolidate sources of data. Sometimes they already exist, but all we have to do is put them all in one place. I mean, this, of course, does not happen everywhere, which is exploratory data analysis, or EDA. And EDA is something that analysts or data scientists usually do with the data that they already have. So I just got a file on the data that we're going to be using and designing models with. So the first thing I would do is trying to understand the data. A small example is if you're measuring the heights of students in a class, and you have all the data on them, you want to know how many tall students are there. How do we define those tall students? What's the average height? And so on. So this is the EDA, which is usually an introductory part of the analysis work. Now, when we want to build models, usually AI workers, or mainly data scientists, machine learning engineers, they start feature engineering. And feature engineering is creating new columns. If I were to model the data as an Excel spreadsheet, the data would be, every data point would be on a row, such as record of a person, and the columns would be the attributes of that person, such as name, height, email address, and all of that. So engineering features is something that these AI workers do in order to enhance the performance of their models and sometimes enhance the accuracy of the model. That is something they almost do every time when they are building the machine learning models. Now, coming to the actual building of machine learning models, which is we choose a statistical model that can take the data and that can predict an outcome. Of course, this step involves a lot of technicalities, but also this step um, aims to produce not just an accurate model, but a model that is easily understood. Now, there's an exemption to this case, which is when we are trying to build a very complex model that understands, that analyzes images or videos. These models usually have so many attributes, so many data that they can extract out of one image. There's the number of pixels, there's the number of lines, the colors of lines, uh, what shapes are in the image. All of that is described in many attributes that several systems, such as the Google image recognition, they can extract from one image. So that is a very complex thing which does not apply to this rule, which is having a logically understandable model. After that, we have model validation. Now they've built all these models and they've done all of that technical work. They need to validate it. They need to make sure that it is something that works in production. After they've validated the models, they implement it. And usually in all of these steps, not just the last few, they need help from all the areas that can give it to them. And more on that in the next slides. So as we have mentioned, the process from A to Z, and this is a very general process, of course, let's try and extract what are the non-technical aspects of that process. What does not require programming and does not require at least a lot of statistical or mathematical background. What you as a non-technical employee or resource, what you can do is contribute to defining the business problem. And as some know, defining the business problem usually comes from either management or some expert in the field who can define the problem well, including mentioning what could change if that problem was to be solved. So, and by doing this, they enable the artificial intelligence workers to focus on a narrow area surrounding that problem. They tell them where exactly to focus on. And that streamlines a lot of costs, of types of costs, actually, and time involved in solving this problem. And as a domain expert, even when you do not know much about artificial intelligence, you will find that seeing all this collaboration with AI workers will tell you how much you can do just by collaborating with them, because you will find out that these systems or these models have new capabilities, such as we said before, speech recognition and image analysis. So it is empowering for both. Also, we have locating legitimate sources of data. This is very important because data is actually, I mean, if we build the best model in the world, but we have corrupt data, then our model is useless, period. And locating data is something, as probably many people know as well, is something very common. We have many data outlets competing to sell data to different entities. As someone who is participating or willing to participate in a project, if you know sources of data that solve specific business problems, this is very valuable to you contributing to such a project. And as we said before, exploratory data analysis is the step that AI workers or sometimes analysts use to understand what data they have. But let's assume that you have data on student height from 2 classrooms, from 2 different areas of the world, 2 different continents. You may be, I mean, the analyst may be able to show you what is the exact difference, what is the statistical description of the situation, but the analyst or the AI worker themselves, they would not be able to tell you why this happened. And maybe let's take an expert on nutrition. That expert can definitely pitch in on the feeding habits, the nutritional habits of students who come from both areas. Or sometimes the weather may be a deciding factor. So this also, this expertise can help in guiding this exploratory analysis. Also, sometimes when AI workers are studying the variables to build the best model they can, they want to know how these variables interact with each other. I mean, if we had somebody here working in let's say a weather station, and we would be interested in finding out, so how does the speed of wind affect the humidity? I myself, I would just guess that, the stronger the wind, the less the humidity. But definitely that is not solid knowledge, which is what we actually are seeking to enhance our model. If that kind of logic coming from experts is embedded in our models, then definitely we will have very, very strong predictive models. They won't be smarter than humans. They will only include some of the knowledge these humans have. But the upside to these models is that they can keep the analysis going on and on and on and on, because they're computers. So experts can also help assess the approach to predicting outcomes. I mean, let's again go back to the example of predicting the weather and the temperature. So if we're saying that we already understood how the speed of wind affects the temperature or the humidity, but now we want to predict the weather. So analysts do have statistical ways and models to study and come up with relationships, mathematical relationships between these values and that outcome. But this is usually a trial and error if we do not have the actual logic. And the actual logic only comes from these experts, which can tell us that this is how we predict the weather. And usually having that amount of experience embedded in this AI application will give it superiority and will give it competitive advantage over other products. Assessing our models, sometimes, let's say, model validation. And model validation, again, is the step where we have built our models. Now we want to test them. We want to test them using several tools. We want to make sure that our models are not just predicting good numbers for the time being. We want them to be production ready, meaning they can take any kind of data and act logically when producing the output. So the validation can be something such as, let's say, you're identifying types of people for some specific business problem, and you find that your model is identifying type 1, 2, and 3, but type 4 is not being identified at all. And you can see that the data is there, you as an AI worker have uncovered it. But now, in order to explain the logical shortfall, I would say, you would have to go to an expert in the field to tell you what you're missing. Sometimes we are missing one extra piece of data. If we're talking about weather, we may be talking about, we should include how the weather was yesterday. We did not include that in the model. Now that we include it, we're able to identify X, Y, and Z. And lastly, we have the implementation, and this is not general to any work area, because you can be reviewing content, you can be reviewing the user interface, and you can be reviewing even the output of the model, because sometimes experts, AI workers, and everybody have contributed to building this model. But the final implementation sometimes just does not make sense. So it's something that we can contribute to as a general, I would say, population of workers. Now we move on to some examples of real world jobs, some that I myself have worked with. Let's take digital analysts, for example. So digital analysts usually work under product owners, and digital analysts have to analyze the work being done. So in order to do that, you would need to take some samples. Usually when we are talking about artificial intelligence, we're talking about data that is thousands and thousands of rows. So the digital analyst, what they would be, one of their most important tasks is they would go through the data and they would get a few samples, and then they would be analyzing those samples and giving reports on the performance of our AI application. When they are doing that, they would have in mind the business rules, the business logic, and the business objectives that must be present in that in those results. If they find something is missing, digital analysts usually research the reason behind any shortcomings in terms of performance. And of course, and then we have conversational user experience designers. I've worked with conversational UX designers myself. They are liaisons also between the product owner and the IT workers and the AI workers. These employees usually are in charge of creating the conversation. And by creating the conversation, I do not mean that they write all of the sentences and all of the responses. What they are in charge of is, after they have understood what is the vision behind the AI application, and mainly, as we're saying, conversational designers. This is more specific to chatbot projects. They would show the technical teams how and what is the reasoning that the chatbot should have. If somebody asks about this situation and we cannot give them that kind of answer, what alternative answer should we be giving them? And that is their work. And just like the digital analysts, they do not write a single line of code or even work with any mathematical complex algorithms. We also have content writers and reviewers, which is something is more common and more known. And somebody might ask, well, this is not specific to artificial intelligence. That's true, but we also have content writers that write, let's say, variable content, meaning you can write one paragraph which has an empty holder. That empty holder will include the result of our AI tool. And as an example of that, let's say we have a statistical model to ask you a few questions, and decide whether you are a beginner or an advanced user. So of course, this is a very, very simplified, and by no means I intend to simplify the work of content writing, but I mean, something you would be writing is, well, if this is the decision of the AI tool, then I will include this content. If not, then I will include that content. And due to them working back and forth with the business decision makers, sometimes they have more understanding about the project than many IT and AI frontline workers do. Also, we have linguists, and I work with a linguist. I was side by side with a linguist on my past project. So these resources are in charge of educating the chatbots, meaning we have ambiguities, we have things that need clarification. Sometimes we need to teach the chatbot about some way to think. If what if the user includes a verb? What if the user includes this as a noun? So now we need to add the ability to the chatbot to understand if this is a verb or a noun, which is something called position of speech, part of speech. I'm sorry, and usually linguists have to build the linguistic logic behind the chatbots. Now, of course, these are examples of jobs that are dedicated to AI, which is not all what we're trying to present today. More of what we want to talk about is how can you participate? How can you, let's say, dip your toes into the world of AI from your work area? The first thing you can do, let's say you heard about this AI project and you would like to participate, you can offer, given the proper authorization, you can offer to share data from processes within your area. If that data exists and is beneficial to this AI model, you can definitely offer to share it, which is something that you may not seem as much, but it will be surprising if you offer, and it turns out to be something that is needed to make a decision within that AI application. You can also, if you are an expert in a field and you know for sure that you can start recording and logging this data, then you can also do that and share it. And trust me, you will have contributed to one of the most critical phases in this AI process, and will allow you to understand what's happening with that data. Also, as we mentioned before, expertise from your own domain can help increase the accuracy of decision making. And here we have two examples, helping researchers and engineers understand how their models should work, how their models are making decisions. You may ask, wow, this is a mathematical or statistical model, but yes, it does have, especially the simpler ones, they should have a logical way of working. If you ask Zillow, how are you pricing houses? Yes, they do use statistical models, but there is a reasoning behind them. They give weights of importance to the size of the area of the house, the area of the basement, and so on. So each one of these features has its own importance in determining the house pricing, as we know. So what they can also do, the experts in the field who are not technical, what they can help assess whether the current developed models are reliable for making decisions. Lastly, they can help implement the AI application in fields that we mentioned before are not specific to a certain field. They user experience design, user experience design, sorry. So that is something that all types of intended users, whoever can test this AI tool, they can give us an opinion on how this tool is doing. And this is very, very valuable to the team designing that tool. You can also help them on content correctness and other general features within the model. So we've mentioned just a few examples out of my own head, out of what I have seen, but more than that, we would like to approach AI projects with a certain attitude. What we want to know is we have to, if you like a certain area from artificial intelligence, such as NLP or even deep learning, which is very, very technical, you can go ahead and learn more about the process. The more that you understand about that process, the more that you can contribute. Sometimes people say, oh, you need to have a PhD for this, or you need to have a master's degree for that. But that is usually not the case, because this is applicable knowledge. If you keep trying to learn statistics and programming night and day, but fail to apply it properly, then, I'm not going to say that's going to go to waste, but it's going to take you a lot of time to train yourself again with the knowledge that you've already spent so much time on gaining. So if you find a chance to, work with the knowledge that, work with the area that you are seeking to go into or contribute to, then definitely do that. Also, do not listen to negative, uneducated opinions. This is very important because on one side, you have the people that try to discourage you from entering that world just because they see it as complex. And on the other side, you have other people on social media, the culprit of today's world. They try to show you that, oh, what we're doing is very complex. What we're doing is way, way, way above what you currently understand, which is definitely not true. We were talking right before this webinar started, and one of the things we spoke about was, you can, if you just want to dive into the world of AI without having all of the knowledge, you can definitely start learning about data science or machine learning and get up and running within 1 or 2 weeks. So the third thing is this. Some people might say, oh, this knowledge goes back 20, 30, 40, 50 years, but there's plenty of room for innovation because the AI, machine learning, and data science and deep learning, all of that is not something that is decided on yet. We don't have, this is it from A to Z exactly. Even the diagram we mentioned before is not something definite. There are many, many variants of that, and these variants keep coming every day. So there's plenty of room for innovation. Your own unique experience definitely will help shape a new product if you really want to contribute. And this brings us to the next point, is that some of you may say, oh, why should I learn programming? Or why should I learn, any technical skill when there's somebody better than me at that skill? The answer to that is that your own unique skill is something that you already know, And that is exactly what they need in that project. You do not have to feel that your knowledge is somehow not relevant when it's actually hiding so much value for that project. And last, you can augment that unique experience of yours with some relevant skill. And here I've mentioned some of and this is only, please take them as only 4 examples. Do not take them as categories, or do not take them as the only ways. Scrum Masters, for example, are able to manage teams and track their activities and help them organize their workflow. Learning programming languages is definitely the core of AI. If you are looking to go into AI later, you can start by learning a bit of Python or R. Julia has also included some other programming languages, definitely have modules or add-ons that would help them, help the users go into AI, but these are the most known. You can also learn how to use data visualization tools, and this does not need any programming, any coding in order to use. And you can learn about something like IT project management, because eventually going, in conversations back and forth with business managers and the teams that you may be managing, this definitely will give you a lot of experience. So please know this is a fairly new field. Definitely there's a lot of opportunities out there. Having to think about the requirements of AI is really exhausting and sometimes discouraging. But in the field of AI, we do need people who know about different areas. If your experience is unique to you, so have that in mind and approach any project with confidence that you will be able to contribute. And that's it. Thank you. Now we come to questions. Whoever wants to have the floor. Julian?
Absolutely. Yeah. Absolutely. Yeah. Thank you. Thank you so much putting it into perspective. Yeah. So, and quickly, any question, feedback?
The talk was very, very informative, Mohammed. Thank you very much. Are you able to hear me?
Yes, yes, Raj. We can hear you.
Okay.
Absolutely. Yeah. Thank you. Thank you so much putting it into perspective. Yeah. So, and quickly, any question, feedback?
Julian, there is an echo going on.
Yeah, I know, maybe from the technical some error, but
thank you.
Yeah, Mohammed, I want to make a comment. Since I am in the recruitment field, some of the recruiters have a mental block about recruiting candidates who have got Middle Eastern university degrees. But then when I listen to you, I think we are ignoring them at our own peril. The kind of knowledge and the depth and breadth of the talk you gave makes us feel that you're giving some of the US graduates a run for their money. Nobody should assume things or judge people based on the labels, because the skill set can be totally different. So it was a very eye-opening exercise today, listening to your talk. And the way you were answering the initial questions gave me an idea that some of our seminars can be in the question and answer format. Instead of the speaker talking and then you asking questions, today you gave a very new format, question answer. And the depth of the answers you gave was wonderful. And third comment I would like to make is, who can get into artificial intelligence? Is pretty much anybody, I would imagine. What is needed is a logical thinking. He can be an anthropologist, for example. He can think that how to analyze bone structures that you find in, let us say, some Timbuktu. Okay? You ask logical questions, you come up with logical answers. Artificial intelligence, the programming, etc., can be fitted in. Either you learn or find somebody who is trained. So what is needed is logical thinking, which is what you mentioned in your talk also. And fourthly, we also discovered the artificial intelligence can have its limitations, going by the example of Zillow. You know, for example, right now in the West Coast in California, we are undergoing a challenge that many of the employees are allowed to work from home, and they are moving out of more expensive areas like the Bay Area, like San Jose, and they are going to far out areas, because when you are allowed to work remotely, you can work from anywhere. Why pay higher rent? Okay. So in a month or two, the real estate dynamics in the California area, or for example, in the Bay Area, has changed. The rents have come down, the property prices have come down. Okay. Now this is a local development which you need to have the intelligence. Here is where the human intelligence and human knowledge and keeping one's ears close to the ground is much more important than merely relying on technology. Am I right? Thank you very much.
Yeah, I don't know if Mohammed,
Mohammed, did you hear me?
yeah, you have to unmute. You have muted. Okay, Mohammed, can you unmute yourself?
Thank you very much.
Absolutely. Julan, I need to mention that there is a very loud echo.
I don't know if Mohammed. Oh my God.
Yeah.
You have to unmute.
Yeah, I already have unmuted.
You have muted. Yeah.
There is either latency or chorus.
Mohammed, can you unmute yourself?
Absolutely. Julan, I need to mention that there is a very loud echo.
Oh my God.
Yeah.
Mohammed, go ahead. Mohammed, can you hear me?
Absolutely. Can everybody hear me?
Yes.
Cool. So thank you, Raj. Actually, the first question I was able to, the first participation I was able to hear was coming from Raj, and I thank you for the beautiful comment, and I also want to answer your question regarding who is able to join. As you have said, you mentioned an example of an anthropologist. So this is one example of, let's say, somebody knowing the interaction between variables leading to an outcome. I mean, the science of studying variables leading to an outcome is statistics. And that's why they use it in data science. But they only use it because they cannot learn every the information that they need to know for each and every field. So having, instead of studying all these, I mean, they will have to study it eventually because they have to come up with numerical relationships. But having the expertise come from experts will benefit their models immensely. They will have more accurate models that rely on logic, and this will probably even lead to breakthroughs in the field. If you mentioned anthropologists, then this may lead to breakthroughs in anthropology, not because I'm not suggesting that these models are smarter than humans, but only because then we will be able to enter massive amounts of data into that model, and therefore we'll be able to have new findings and even find out some misconceptions that we may have had before. So I hope that answers your question. And I hope that if anybody asked some other question that was where the latency and echo, could you please repeat your question? I know that Venkatesh asked me a question about the about being able to use AI in the pharma regulatory field. And I can go ahead answering right now before other questions. If in the regulatory area, I'm sure that they, let's say we have a committee that is deciding on some pharmaceutical product or maybe even a pharmaceutical process. In order for them to back their decision regarding that, they would have to study that process using numerical features, such as the time taken to do XYZ, or if we're talking about drugs, we know that definitely a lot of research goes into these drugs, such as trials. I'm not sure if you are close to that area, but okay, so that is generally during drug development, and collectively we make. So yeah, Venkatesh is asking, they usually collect data that is generated during drug development, and this drug development is usually phases of trials. Of course, the final verdict on the products come out after having massive amounts of data. I'm not sure of the amount of experiments, but that data by itself, being combined with past decisions, if we're talking about a drug, then what you may be able to do is getting past data about other drugs that have been either approved or not approved. But in that case, you would say, this is the data and this is the decision. This was approved and this was not approved. And this is what we call annotating that data, meaning we already have the data, which is the input, but because it's also past data, we already have the decision, the final decision of whoever approved the drug. So that is very valuable information for a machine learning model if you could represent it in the right way, adding that this has happened and this was decision, and feeding that into a machine learning model will enable you to predict with certain confidence that this drug will be accepted or refused as you get the new data for the new drug without having to wait. Of course, it's not going to predict with 100% confidence, but it will give you an idea about whether this drug is to be accepted or not. And I hope this somehow closely answers your question.
I'm afraid to speak now. Can you hear me properly?
Perfect.
Okay. Oh my God. It was like, yeah, I think, yeah, it was answered perfectly. Any other questions? So just before we take
Yes,
in any
Julian.
more, yes, please go
We have
ahead.
one question in YouTube asking by B. Why do you think someone like Elon Musk would warn us against using AI?
Okay, so I think this is a great question. The reason behind the risks we perceive in AI applications is not AI applications themselves, or in a different way. Let's answer the risks associated with AI can be divided to two parts. One is the risks associated with the AI application, and that you associated with the humans using AI is much more. If we're talking about individuals who can use AI to, cause damage. Up until now, nothing has been out to the market that uses them, as far as I know. But I know that AI has the capability to sift through websites, sift through emails and accounts, and start searching and start trying, using human-like capabilities to hack someone or to, cause damage online and otherwise. So, we can all imagine what the AI knowledge can do for a person with wrong intentions if they have drones or other devices that use AI. So that is one thing I would imagine, and I hope this answers BYB's question.
Mohammed, can you give me your email ID? Because if I have any questions or any other discussions, I can contact you. Is there an email ID where we can reach you?
Yes, absolutely, Raj. I'll send you my email ID in a second. Okay. So does anybody have any other questions?
Yeah. What is it? Can you do it again, please? I didn't read. I saw MO some port. Can you type it again? Can you show it again?
Yeah.
Thank you.
Absolutely. So
I don't think anything else can go wrong today. I mean, any more things. So yeah, with that, yes, as I was saying, that it's Tuesday, Wednesday, Thursdays every day from noon Eastern time, and tomorrow we have a very important topic, the power of potential, unleash the power of potential to become your best self. And on Fridays, we have Let Us Talk It Youth series. And this week we have the topic, the importance of co-curricular activities in school, like spelling bee, GOB, maths and science, Olympiad, and many others. So the kids are working hard. We wish and we hope that you would join these webinars, encourage us. And thank you, Mohammed, so much. Sorry for all the technical difficulties.
Thank you, Julan.
Yeah, Julan,
Yes.
this is one more reason why you should use AI in conducting these seminars, because it'll generate a predictive model of what can go wrong.
It can go wrong anywhere.
Here is a practical application, okay?
Yes, I'll be talking to Mohammed soon about it.
Thank you very much. And Mohammed, it was wonderful. And the time is 40 minutes beyond, but then we would have spent another 40 minutes given the nascent nature of the topic. Appreciate your patience in handling our questions. And it was a wonderful, wonderful webinar. Quite rewarding. Thank you and appreciate your time.
I appreciate it. That's my pleasure, and I hope everybody could benefit from what we spoke about today. Thank you.
Thank you so much. Totally agree with what Raj said. Thank you for your patience. Thank you, audience, for your patience as well. Thank you, everyone. Have a wonderful day ahead. Bye.
Thank you, everyone.
Yeah, thank you, Venkatesh.